Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with chemistry spectroscopy. And this is the chapter on ultraviolet visible spectra, and in this chapter this is lecture number 43. In this lecture I will explain you numericals based on Enone system. For example, this compound is given to you. In this case you can see COOCH3 group is present over here. And this group is known as ester. If you split this ester COOCH3, it will be like this. That means it is basically carbonyl group. So it is carbonyl group, and now with this CO there will be single bond carbon-carbon and C double bond C. So this is our system. So our system starts from CO, single bond C, and C double bond C. Okay, so this is our system. So here, what is Z? Z would be OCH3. So this is called Z, and here Z is equal to OCH3. That means it is ester. Okay, so what will be the base value for this? Let us find out this. When Z is equal to OR, that is ester, then base value will be, well, this base value is given to you. You don't have to remember it. It can be either 193 or 195. Whatever is the given, that you can take. 195 nanometer is the base value for ester. Next. Now, we have to find out whether are there any extra conjugated double bonds or not, or can we extend the systems or not. Yes, because there is single bond over here, then there is double bond. So again you will find one more double bond over here, so extension of system is possible. So that will be extra conjugated double bond. And in this extra conjugated double bond, which is 1, so we will put 30 nanometer extra for this. Okay, so here we have kept the 30 nanometer for extra conjugated double bond. Now next thing is exocyclic double bond, if there is any exocyclic double bond present or not. So exocyclic double bond, well, there is no cyclic ring, so exocyclic double bond is absent, so we will keep 0 nanometer for exocyclic double bond. Next is substitution. So before we find out substitution, let us find out first of all alphabetical order of all these carbons of the system. And so we will keep this number as the first carbon with the functional group is C, this one. So we will call it alpha carbon. This is beta, next is gamma, and then delta. So these are 4 carbons of the system. Now we will find out what is substitutions with alpha carbon. This alkyl group is attached to this, so that is called ring residue at alpha carbon, and therefore we will put 10 nanometer for alpha substitution of ring residue. Next is beta carbon. Beta carbon is also having one CH3 group, that is alkyl substitution. So at beta carbon again there is one ring residue, that is substitution of alkyl group. So for that we will put 12 nanometer. Next, gamma carbon. So gamma carbon is having substitution of OH group. So when OH group is present at gamma carbon, the value is given 0. That is given, so we don't have to remember all these values. But when OH group is present at gamma carbon, we do not write anything. Now next is delta carbon. This is delta carbon, and there are 2 ring residues, 1 and 2 with this. So 2 ring residues at delta carbon, and for the each one we will put 18. So there are 2, so 36 nanometer for this one. And now we know all these things, so we will add all these values and find out lambda maxima for this compound. So that will be your answer for this compound. Now we We'll go ahead with the next compound, this one. Okay, here you will find there are two C double bond O and one double bond is in the system in the ring. From the beginning, it looks like there is no conjugation between C double bond O and this C double bond C. So this is not either diene, enone or benzoyl system. But it is not true. Why? Because when carbon attached to C double bond O carbon is having hydrogen and this oxygen being negative, you will find tautomerism. And in tautomerism, the hydrogen from alpha carbon will shift to the oxygen and we will have a new structure of this compound that we can draw like this. Here there is a double bond. Now when hydrogen will shift over here, then instead of double bond, now there will be single bond and it is OH. And double bond will, pi bond will shift between carbon and carbon. So now double bond is over here. Now there is one alkyl group over here, one alkyl group here, and this is the structure. This C double bond O remain the same. Okay, so now we consider this compound, and here in this compound there is a system. Which one is a system? C double bond O, C single bond C, and then C double bond C. So this is our enone system. And in enone system, well, we have this double bond is in the ring. So where is Z? This will be Z, and the Z is carbon, but it is a part of 6-member ring. So now our system is enone with Z is equal to carbon, and this carbon is a 6-member ring. Why? Because this C double bond C is a part of this 6-member ring only, and therefore we will consider this carbon as a 6-member ring, cyclic ring, and for that we will put 215 nanometer for as a base value for enone system. Okay, now next is extension of this system is possible or not. Yes. Why? Because there is single bond carbon and then C double bond C, so we can extend this systems up to this carbon. Okay, so next is we will try to label each carbon. So this one is alpha carbon, next is beta carbon, then gamma carbon and delta carbon. Okay, so next is to find out extra conjugated double bond. Is there any extra conjugated double bond? Yes. This extra conjugated double bond is in a green line, and for that there is one extra conjugated double bond. We will put 30 nanometer for this one. Okay. Now one more thing over here. This C double bond C, which is in a yellow between alpha and beta, and the C double bond C between gamma and delta are in the ring and both are cis. So these two are cis. As you can see, both are in the same ring and they appear cis. So here we will put cis, that means homoannular diene component. And if this extra conjugated double bond is homoannular diene component, we will add 39 nanometer for this one. Okay, so this double bond is cis conditions, that's why we have kept 39 nanometer for this one. Next is exocyclic exocyclic double bond. So is there any exocyclic double bond present or not? That we'll have to see. Look, if C double bond O is exocyclic, we will not consider that as exocyclic. But now we have to see from next double bond of the system, that is alpha, beta, gamma, delta. These two double bonds are endocyclic because all carbons are in the same system, same ring, and therefore there is no exocyclic double bond. And therefore we will put 0 nanometer for this one. Next is substitution. There, well, there is one alpha carbon over here. At an alpha carbon, we have substitution of OH group, and for when alpha carbon is having OH group, we will add 35 nanometer for this one. Okay, next is beta carbon. This is beta carbon, and there is ring residue over here. So at beta carbon we have alkyl substitution and ring residue at beta carbon, so we will add 12 nanometer for this one. Next is gamma carbon. Gamma carbon is also having one ring residue, so we will put for that 18 nanometer. Next is delta carbon, and there are two ring residues with delta carbons. So when there are two ring residues at delta carbon, for each one we will put 18. So 2 into 18 will be 36 nanometer. Okay, so this way we have kept this one. Now one more thing. Here we have not mentioned what is solvent used for this one. So as solvent is not mentioned, so we will put solvent correction 0. If solvent is mentioned, for that also we will have to add some value if for certain solvent. Okay, but if solvent is not given, then you don't have to add anything. You can put 0 for this one, but you have to mention it. Okay, all values will be given for solvent corrections also. Okay, so now we will add all this to find out lambda maxima for this molecule. Okay, so this way sometimes from the first view we will not find that this is a system enone or diene or benzoyl, but it is a system while considering tautomerism, and this is known as keto form. And as there are OH group and double bond over here, so it is called enol form. So enol form becomes Enone system, but there is no Enone system in keto form. But then we'll have to change it and find out the lambda maxima. So this way there are certain tricky examples given to you. Please be careful. That's it in this lecture. Thank you so much.